Hello everyone, my name is Yingdan Lei. I'm from Triple E, and today I want to talk something about transparent ceramics. First, do you know anything about solid-state laser, which means light amplification by stimulated emission of radiation? Here there is a simplified structure of solid-state laser. Here are two mirrors constituting a laser cavity, and there is a laser gain medium inside the cavity. For the gain medium, there are many ions stored inside. So these ions can be pumped from these pump cells. They can pump from the lower level to a higher level, and then quickly jump back to the lower level with a laser emission. This process will repeat many times inside the cavity, and then the light, which is amplified and has a very good coherence, will come out from this mirror. Here are two pictures of laser. Traditionally, solid-state laser is made by single crystal, but in 1995, a paper compared these two materials and found out that the transmittance of transparent ceramics and single crystal is almost the same. So we can look at this picture. These two lines is very close to each other, and this is the photo of YAG single crystal. This is YAG transparent ceramic. We can see they looks quite same. What's more, ceramics have some advantages over single crystal. First, the cost of ceramic is much lower than single crystal. Then it's very easy for transparent ceramic to achieve a large scale and various shape. But the shape of, we all know that the shape of single crystal is determined by its lattice orientation. It's not so easy to control the shape of single crystal. Then another advantage is for transparent ceramics, they are easy to dope ions, and also very easy to control the concentration of the dopants. We all know traditional ceramics are opaque, right? Look at these pictures. We are very familiar with traditional ceramics. Here are some functional ceramics, ornamental ceramics, and structural ceramics. So, why ceramics can be changed from opaque to transparent? We can see the microstructure. We all know that for traditional ceramics, here are many impurities or pores inside or on the surface, right? So when light comes in, it is scattered, reflected and absorbed by the surface and the inner part of the ceramics. So we need to control the sintering process to avoid all these defects. And if we eliminate all the defects inside or on the surface of ceramics, it is possible for ceramics to become transparent. The fabrication process of transparent ceramic is quite similar to general ceramics. first we prepare the powders. The quality of powders are really important. Here is a new method here's a new method to prepare ethyl powders, which is chemical co-precipitation. This chemical reaction is very simple and it happens in liquid. After the reaction, we got the precipitation. The advantage of this method is that we can get the powders with very good dispersity and excellent sinterability. Then, next process is ball milling. Generally, we use ball milling to break the agglomerates within powders, which is really bad. For the sintering process, and ball milling is also very useful to mix the sintering S and dopants together. Then we press all the powders. Generally, we use dry press and CIP method. After the pressing process, we get green bodies of ceramic. Then here comes the sintering process. There are many methods to sinter transparent ceramics, which includes vacuum sintering, HIP, and SPS. The vacuum sintering is the simplest sintering method. For each transparent ceramics, we usually sinter this material at 1600 degree to 1800 degree. But recently, a new method is proposed by researchers, which is two-step sintering. And using this method, some researchers got very high quality ceramics with higher density and a thinner grain boundary. One thing I need to emphasize is that there is a huge gap between 99.9% and 99.99% of theoretical density in terms of sample quality. Look at this picture. These two samples looks totally different, right? One is opaque, but the other is transparent. But actually, the difference of density of these two samples may be no more than 0.01%. So we can see it is for transparent ceramics, it is necessary to achieve the full density. And there are many other applications of transparent ceramics for its excellent mechanical properties and thermal properties, like transparent armors, camera lens, artificial jewel, because it looks very similar to single crystal, missile domes, and aerospace windows. So we can see transparent ceramics will be a very useful material in the future. That's all I want to introduce to you. Thank you for your listening. Thanks.